Hello and a warm welcome to today's Smart Factory Summit 2025, second session this year. And once again, a warm welcome for all participants that we now have in our round, and of course, also from our colleagues that will present topics that we'll discuss afterwards with you, several topics that might be interesting for you as well. So many new interesting items, new features, new elements that we will have to present. And to go a little bit more into the details and insights, what we planned for today, let's have a short look at the agenda, Alina.
Yes, so thank you, Andreas, and welcome also from my side. My name is Alina, and I'm responsible for marketing over here at iTAC. And I want to go through the agenda with you so you will see what you can expect during the next 3 hours. So we have Andreas, who you've also, already met over here, and he will present the portfolio of our group of companies. And then show you which various industries we can serve and what benefits you can have from that, basically. And then he will continue with the second topic, which will be about our new product, iTAC.CATi. And CATi is our new chatbot that can be used in production. And you can ask this chatbot various types of questions. So it basically works as some kind of personal agent for some technical insights. But you will see that in detail in Andreas' presentation, because he will also then show a demo. And after that, we will have 2 sessions on advanced planning and scheduling, hosted by DUALIS. The first one will be ready for APS, which will be held by Heike Wilson. And then she will tell us why it makes sense to implement an APS system and not just to rely on an ERP system for planning. And then she will also provide some guidelines regarding implementation of an APS and usage. And the topic after that will be presented by Ferdinand, and he will give us some insights on predictive planning using AI. So it will also be about artificial intelligence. And then roundabout at 4:15, we have Julie from Cogiscan, who will show us how to manage moisture-sensitive devices in electronics manufacturing. And then last but not least, we have Albert from Accevo, who will tell us about microstops monitoring and how to prevent those machine stoppages, basically. And before I hand over to Andreas for the first topic, I want to say some organizational things. So you have the option to ask questions during the session using our Q&A button, which you see on the bottom of your Teams. And we will try to answer these questions in or after the sessions. If we don't have the time, we will definitely get back to you after the session or in between in the chat. That's also an option. So feel free to ask questions, whatever you would like to ask. And yeah, we will definitely answer that. I guess this is it from an organizational point of view. So I guess we're all ready to get started. So Andreas, I would like to hand over to you for the first session.
Yes, thank you, Alina. So we are more than on time, 5 minutes ahead. So let's go into our portfolio at a glance. First of all, I'd like to introduce myself. Alina said already, Andreas Zerfers. I'm responsible for the iTAC Group portfolio. That means for all the companies that belong to the iTAC software. We will just see a little bit more details in the next slides about companies, product portfolio, branches that we are providing software for. But first of all, the mother company that we belong to is the Dürr Group. I will give you some insights here as well. So the Dürr, which is a worldwide leader in mechanical and plant engineering, very famous for paint shops, developing and providing paint shops across the globe. It's interesting for us because it's a solution that also facilitates software from our side. So we can bring our knowledge also into the Dürr Group. And also interesting the numbers. So it's a big company last year annual sales of 4.7 billion euros, and across the globe, approximately 20,000 employees in 139 locations on 33 countries. Why it's important and interesting for us? Due to the fact that they have locations across the world, we can also provide support and locations that our companies or our customers need, for example, as counterparts contacts in the individual areas where they have facilities, production sites, plants. The portfolio from the Dürr Group consists out of several areas. One big area is the paint shops, as I already said, final assembly lines and test systems, which is the automotive sector. We'll see an additional slide that's the most important area for us as iTAC Group. And it makes also the highest part in the sales area, 2.1 billion. Additionally, they have also production automation, balancing, battery production technology, which is quite new. And a big additional part in the group, Dürr Group, is the woodworking technology. This is HOMAG, also number one player in the world, providing machines for wood fabrication. The last part of it has been sold this year, and environmental technology, still on the slide, but by the end of this quarter, it has been sold to an additional company, so no longer belongs to the Dürr Group itself. This slide shows you where iTAC and also the companies from iTAC Group belong to. It's, as I said already, the automotive sector. When you read through the individual roles, paint shops, paint application technology, final assembly systems, there are items inside where our software stack can be very helpful for providing solutions also for these customers. And that's the reason why we have been acquired in the past by the Dürr Group, and we are now together building up a digital factory to provide solutions together for the whole group. On the next slide, just to give you a short insight what we are doing together with Dürr. It's named Dürr Digital at Dürr, the digital factory. They started this several years ago with approximately 240 developers in 22 agile teams. Interesting story is here, as I said, that we are together developing a state-of-the-art application, a platform that will help our customers facilitate solutions on a modern cloud platform. Typical things that or companies that work with us already in the traceability area or production management area will be then provided as a microservice-based solution in a Kubernetes world. We have been already cloud ready, but with this new approach, all the solutions are brought together, provided on a common platform without media breaks, authorization, authentication, single sign-on, all the things that are necessary to be modern, to be straightforward. Also, the possibility to have their an event-driven modular design is then enabled. So, as I said, a state-to-the-art design, state-to-the-art technology, and end-to-end solution for all the customers. Maybe you read sometimes the description or name DXQ Control. Sometimes you read iTAC MOM Suite. It's more or less the same product. It's only the angle from which this product is sold or looked upon. Dürr is selling it as a DXQ Control product, and we are selling it as iTAC MOM Suite 11 and higher versions. Quick journey to iTAC. iTAC has been founded in 1998 as a spin-off from the Bosch Group, already challenging strategies to track and trace units, production orders with a unit quantity of 1 So high variance was already something that we needed to track and trace. Also in terms of quality control, that all products that we tracked are compliant to the ERP definition, to the customer's sales definition. So that's what has been done in this year already, as they defined it in the Bosch side. Later on, after selling or going into the direction acquiring venture capitalists, we changed the name a little bit. The product was still the same. It was called EasyWorks, but in 2001, the story started to become bigger and bigger. And we launched then in 2006 the product iTAC MES Suite, which gathered more and more functionality besides what has been defined early days in the Bosch environment. In 2015, we have been acquired by the DUR, and the strategy, which I explained already, was and is still to define, develop, implement solutions together with the software departments that they also have, and to bring solutions together. One example is that they have a maintenance management solution, and we bring both worlds together. So maintenance manager from DUR is combined with the iTAC MOM suite or MES suite together, so that we can provide maintenance orders, track and trace maintenance, track and trace repairs, and so on. In 2016, important acquisition was done by getting DUALIS into the group. It's very important in the portfolio of an MES product or now MOM product that you have also a planning expertise and also the capability to do fine planning. And this was then possible from 2016 and further on. In 2020, we started an initiative together with DUR to change the technology. Until 2020, we had a big monolithic architecture. We still have it. It's a very good solution. It's stable, but the challenge was now to go into an architectural design, technology transformation that will give us opportunities to change components a little bit faster, to migrate, update components of our whole product portfolio faster, and also to integrate other solutions easier as it was in the past. As I said, in this monolithic approach, it was not that easy to integrate additional solutions. And with this newest approach that we started in the concept phase and then later on also implementing, this is the strategy to define a platform, a common platform, integrate easier, exchange components easier on the customer side, and be faster. In 2021, we had an additional important acquisition of Cogiscan, also besides DUALIS, one of the presenters today. Why it's important, as we have been very strong in the electronic environment. It was a good decision also to acquire Cogiscan, as they are very strong in handling shop floor equipment in electronic manufacturing, big experts there. And so it was the right decision just to take them as partners and as a sister company into the group. In 2024, last year, we had also the integration of Accevo into our group, which is an additional MOM system. I will give you some insights a little bit later, but also important as we can now cover multiple segments, branches with our platform in the future. So also very important decision. In 2025, we had the first implementation of our MOM 11 product. So we had there the first initial customer who wanted to go the next step together with us. It's a greenfield customer, so it's not brownfield solution. So we are, first of all, evaluating everything in terms of what is possible, what needs to be done, how to shape the solution together with this customer. And we're quite happy that we are now in next year going to finalization for this customer and scheduling at the moment the go live. Some additional facts about the group, different locations. So let's say core locations where we have also offices inside Germany, China, Canada, Japan, Mexico, Poland, Tunisia, and USA. But as the Dürr Group has additional offices, it's also possible to support at least some kind of contact. The product itself is now named iTAC Mom Suite for several years, but we have a new product area or product group. Besides the Mom Suite, it's the iTAC MA Suite, and part of it will be presented in the session when I'm talking about iTAC.CATi, which is belonging to the iTAC MA Suite. We are providing several services, consulting, project management. We do the integration and, of course, training and support for all our product portfolio elements across also the partner solutions. So we are one point of contact if it's about support issues that you want to mention or wishes, changes, features that you want to have in our product portfolio. To give you some numbers about the size, iTAC itself has approximately now 145 people without looking at external employees or external contractors. And when we are looking at the group has 450 people approximately, including, as I said, all subsidiaries. As necessary for all of our customers, so with the focus in very special areas, but also automotive, we have the necessary certifications. So 9001 quality management system, but also information management system, TISAX, and we are partner of the OPC Foundation. Very important as we have a very strict philosophy in adapting machines, shop floors. So also the strategy then to talk to these technology providers. An important slide to understand which subsidiary or which brand does what for the group. On the left-hand side, iTAC software itself, starting with a typical MES-MOM portfolio, including analytics features. When you compare it to the right side, Accevo, there's also mentioned MES-MOM, paperless. So there are, from the first view, many overlaps, but the market is slightly different. That's the reason why I said we are now covering more branches, more areas, more markets. iTAC is focused on discrete manufacturing and everything around, where Accevo is covering more the process manufacturing side. Also capabilities to do discrete, but the focus is more on the process manufacturing side. And we can cover both solutions across the globe. iTAC China is facilitating or reusing the products from the group, and they are enhancing it a little bit with their own solution, which we sometimes also sell to customers. Very interesting solution, for example, is the solution where we have material transports, material calculations, especially done for the Chinese market, but we have seen that we can adopt it easily also to other areas. So if you're interested there, additionally, we can talk about also the portfolio that they offer. DUALIS, Heike Wilson will just start after my presentation, is providing two different products. The first item is the production planning, APS, advanced planning and scheduling, which we have integrated without any media break. That means exchange of master data and movement data to the planning engine is immediately done, and the result after the planning execution is sent back. And of course, due to our integration to ERP, we have a seamless integration, end-to-end integration from ERP to the shop floor to the planning back and forth. And Cogiscan, as I said already, has a very special expertise in the SMT area, where they offer special SMT services, analytics tools, and connectivity to the shop floor. Offer also some hardware solutions in this area. So a very valuable enhancement for our product portfolio. To understand in which, let's say, market segments, which company has which focus, just a short overview. I do not want to go into the details, but as I said, we are now able to cover many areas, many markets, and the only market that we can cover today with only one company, Accevo, is fast-moving consumer goods. But as you see, we have solutions across all individual markets that we now can offer. Interesting for companies that start with the pre-manufacturing area, pick and place, for example, final assembly. So 3 different segments that have to be brought together and that need to use the same solution. Our product is tracked and traced also, of course, by companies like Gartner. Gartner is meanwhile changing a little bit the strategy. Until last year, they released the Gartner Magic Quadrant. To this year, they changed it a little bit. They have now the so-called Gartner Peer Insights, where our customers have to rate our product. And we are very happy to be there, nominated with 4.8 out of 5 stars. So from our point of view, a very good rating and 100% willingness to recommend our solution. And also the rated categories, when you check it, it's the typical home turf where we are inside and rated quite well. And just a look into what we have seen last 2-3 years, always the Gartner Quadrant. We have been there in the leader position besides big companies, and sometimes even in terms of visionary, a little bit ahead. So always interesting new solutions. And one of the solutions will be presented today, iTAC.CATi, which is a chatbot driven application that we integrated into our solution. I would like to highlight 3 additional topics where we have been rated as number 1, for example, here, complex, discrete manufacturing use cases. All the customers, all the partners, all people that know iTAC quite well know that our strategy is to be most precise as possible. That means integration into a EP world, bill of material adoption, work plan adoption, process adoption, as complex and complete as possible, and also to have there an immediate feedback. That means we validate always what is inside the master data, and during the manufacturing process, we give immediately bidirectionally feedback from the shop floor. Is the date that you're uploading, the content what you're uploading, valid, not valid? If it's not valid, why? So it's a complex thing that we are doing there, but our customers are very satisfied with what we are doing. That's the reason why we are number 1 there. Second, in batch repetitive flow manufacturing use cases, similar to the discrete one, but with a higher load, with a quantity-based approach, and with highly regulated industry use cases. Also second, so one example could be mentioned here. We have the FDA regulations that we need to fulfill for several customers in medical area, for example. And that's exactly what our product is for. Automation, highly grade of automation, but making things easier, even if it's a very complex, discrete manufacturing use case or highly regulated. So before we go to the product, final look at the iTAC locations. So once again, across the globe, all the companies that provide value for our customers have locations in Northern America, in China, Asia, Europe. So everywhere where production processes, where manufacturing is done, typically iTAC is also available with an office, or our partner subsidiaries are available there with a partner location. Well, that was the insight into our iTAC group. First of all, let's take a short breath and go to the next topic. We are quite happy, we're very happy to have a new product in our portfolio. It is, let's say, an enhancement of something that we had in the past, but we implemented something on top of it, which makes it to an advantage or an advanced chatbot in comparison what we did before. So let's go into the detail. Which challenge did we face, and what architecture and solution did we implement? It's first of all, we have MES data, MOM data, somewhere in a big, huge database. Very often, you need to create reports to get data out of the system. A typical situation that we see at customer side is that our typical, let's say, persona, so people that want to extract data, has their individual approach how to do it. So you do not very often have, this is the standard report. You can start with a simple template, report template, and give this as an introduction or an intro. But sooner or later, they change these reports and adjust it to their needs. Enhance it, cut things, have their own formulas to calculate KPIs and so on. So the way how to extract data of an MES is typically very hard when you do not use the standard way. In our dialogues, in our applications, in the workplace or in the workbench, we have our standard dialogues with which you can be quite fast and get the necessary information. But when you want to combine things, which is not defined in a report, in a standard report, then it's starting with implementation, so concept phase, doing the implementation, testing, and so on. Very often you have also information in data. That means uploaded content, PDF files, test results, whatever. And sometimes next challenge is that the knowledge is stuck in the head of people. The issue appears when people are leaving. So as long as people are there, everything is fine. You do not need to train additional things, but as they are going to leave, and now with looking at the generations that will go to retirement, you need to look ahead and decide how to train new people, how to enable these people so that they can do the same job as the people that are leaving. So this is also a challenge. How do you do the training? And sometimes you maybe have forgotten to show a very special case, and maybe ChatGPT or something like this can assist here as well. An additional challenge is that the so-called large language models, the LLMs, are very often isolated and cloud dependent. That means the machines, the computers, the compute power that you need is typically located in the cloud, and you need then a bridge from the on-premises installation, so from the shop floor to the cloud, transfer data vice versa, when you do training and do the validation. So that could be also a challenge. And typically there is, until now in the old MES, just looking at the old MES, no natural language interaction. So you cannot ask something and you get a response. So you have their clients which have to be implemented with filter segments, and then you get the result in a table, chart, or whatever. Our solution is to implement a ChatGPT approach so that you can have a conversation with the MES content and additional data like standard operating procedures. An additional benefit, which is very important here, is that we can have any natural language that is known to our AI engine. So example is you have the documentation in German and you're asking something in French and you get your answer in French and it translates it automatically. So can this technology already be used just on basis of things that we already provided in the past? Quite easily. We have also security implemented in our solution. As we say, it's important for us to keep the data on premises, but these large language models that are typically executed in the cloud will be in the future provided also by iTAC on premises, so that everything can be on premises from the execution side. You do not have the need in the long run to have a cloud dependent solution. Unified knowledge based on MES data, ticketing, documents, documentations in general. We are also looking into the area where we want to facilitate and use the things by ourselves. So my slogan is here, eat your own dog food. So we have also systems like BCS for ticketing. We have their Jira and Confluence for our developers to track and trace tickets, but also to store some developer documentation, requirement documentation, and so on. So it would help to combine all the things when a support issue appears and you want to analyze it. And that's then one of the solutions that we will have in the future, combining everything. So not only MES data, documentations that we already have, but also ticket systems and other sources like Word, Excel, PowerPoint, whatever is available. And then with the guided actions, get then information what could be done when which issue appears. So solution is defined from our point of view, and we did it based on a product that we already provided and presented several years ago. It was called Ask Our Docs. We relabeled this product. It's now called iTAC.CATi Docs. It is an interface, a multi-language large model interface, which can be used ChatGPT-like to access all the documentation. And I will also give you 2 demos at the end of today's session in this environment iTAC.CATi, show you how you can use this iTAC.CATi Docs and how we can use iTAC.CATi Pro, which is now the enhancement of not only using iTAC documentation. iTAC documentation could be IMS API documentation, ERP service implementation, the workplace or workbench documentation. We can put now also MES content inside. So you can ask typical questions that someone from shop floor would ask. What is my production performance on production lines? Something. And the system will give you then an answer, maybe with a table, and the table content then will be also presented in a chart. A next level that we do not currently have, but we are working on it, is to combine everything with additional data, with additional content. As I said already in the slide before, we want to combine also Jira, Confluence, BCS, documents from Office, Excel, Word, PowerPoint, to get the information which is already there into context of maybe support actions, support activities, and additional things that maybe are in your environment as well. So from the architectural point of view, it is a seamless integration of nearly all the content that is around or besides the iTAC MOM suite. We want to group it. We want to bring it together. We want to offer very easy and understandable interface, namely language, easy language. Just type in what you want to have and you get the result. We are doing it by interfacing to other systems, and we are also providing the same interface technology that we are using for Jira interface. It's called MCP, Model Control Platform. It's a service, or let's say something like an API, interface with which we can request data and get the answer from this individual system. So the integration layer is typically mainly MCP, and we're bringing then everything together in one single instance, which is then called iTAC.CATi. Additional sources like standard operating procedures will be something like PDF documents, manuals, errors, ticketing systems, and everything will be secured by our own authorization and authentication. So you need to log in. When you're using the new workbench in future, it will be a single sign-on usage. So one single dedicated login. And then you can use every application, including iTAC.CATi, without need to log in additionally. In the past, you had to log in into each individual application. In the future, with the newest platform, it's not necessary any longer, as all the HTML5 applications are providing single sign-on functionality. In our chatbot, CATi, it's also important to know that we do not only get data out of the database. The database itself is well formed, but you need to know which data is located in which table and how are the relations between the tables. So you need an understanding of the content of the database. And that's the reason why we are using knowledge graphs here to define a context on top of what we have in our database already. Maybe as a side notice, not written here, but we are using the iTAC views, which have also a documentation. That means based on the iTAC views, we can extract nearly everything that is described in these views in the documentation. But we also implemented with the knowledge graphs typical question paths. So what do you want to analyze and what is the path how to analyze it? It gives us the security to get the right answers. The systems nowadays are so intelligent and interesting in use. So if this chatbot from iTAC.CATi does not find the right knowledge graph, it anyhow tries to use documentation, for example, the IMS view documentation. And if it finds a content that fits for your question, it tries to use the view and gives you an answer. So quite interesting that it exceeds also the possibilities to what we implemented already. So how does it look like and how does the application work? As I said, you will see it online. On the left-hand side, you see first of all the application requests comparable to what you know from ChatGPT. So you can ask then with a new chat, and it's uploaded in the future, and then here as repetitive chat history, what has been requested. You can see only the chats that you requested. You can reuse it, but you can only add questions in an area where you are allowed to do it. In the blue box, you see the connected data sources. By the way, how we are integrating it using MCP, you can see all the MCP sources or SQL sources or whatever is attached. And of course, the logged in user that is currently facilitating the application, because we are really using at the moment features from Azure. So there is a single sign-on call to Azure done as well, and we are forwarding then the authorization to Azure at this location. So how does the result look like? After you key in your question, then typically, as you know it by ChatGPT or Copilot, you see the question again, and then you can see below the answer, including also the data source. So for us, it's important to give us, especially in the first months and years from implementation, the feedback, where did I get this information from? Also to validate, is it a true answer or is it something that I need to filter again or set a more precise question to get the answer that I really intended to get. And then you receive charts, tables, whatever, that are a little bit more user-friendly. Currently, we are providing the tables with the content and initial charts, but in the future, it will be also possible to link later on the answer to maybe the workbench location where you can go into additional analytics. So when you want to see a serial number history, for example, you can get initial requests or information here, but you can go also to the dialogues that you already know from the workbench. Typical benefits that we think is possible with our product, and that's also that our colleagues that used it initially said that is exactly what we think that will be the effect, is root cause analysis can be speed up. We have definitely an improved compliance and transparency, as we can key in data, search for serial number, search for something, and you will get it immediately without the need to go into the workbench plugins or in the workplace dialogues. So that could be an initial approach, but when you want to go a little bit deeper, it makes maybe more sense than to go back to the typical reports that you have to get it directly and structured. But this could be an initial approach to find it. Continuous learning, of course, I think this is a very important thing, as we definitely have the possibility to enhance the system constantly by new knowledge graphs for future queries. So with every new request to our system and with the derived knowledge graph, we can enhance the system month by month, year by year, so that it really gets an assistant that helps you side by side by the execution of the daily work. In terms of scalability, we have there a multi-site operation, of course, which will integrate content from different individual sites, production sites. So when you want to compare things, it's also possible with the BI report, but also ChatGPT based iTAC.CATi will be able to do it in a similar way. So compare production line A in site 1 with production line B in site 2. That will be possible in terms of OEE, quality, defects, conditions, error conditions, whatever might be important and necessary. And part of it, of iTAC.CATi, will also be that we integrate our AI technology into the asset analyzer for the downtime tracking to cut down the time that you need to define the real machine condition, and later on, optimize, of course, the calculation of your KPIs, and of course also in terms of energy usage, when you have the option to change the performance of the machine and the machine park itself. So how did we implement it? We thought about people that are using it, and that's the reason why we defined persona. That's only an excerpt of what we did in the past. So we have the group leaders, we have line supervisors, shop floor operators, process engineers, IT people, or people that do digitalization. So for every group that we are looking at, we try to find questions. What would be a typical question that they need to get an answer for? So the group leader has more the look across plants and teams. the line supervisor, more the view, what is going on in my production area, shop floor operations, more fixing issues, doing maintenance, the process engineer, more checking the root causes of issues that either are located in an equipment change or an equipment defect or whatever. And IT is, of course, also interested in usage of technology, facilitation of data transaction, and reducing these transactions as transactions which can generate value, also generate cost. So this is then the approach has been the approach to focus on the need of all our customers and to derive then knowledge graphs, answers, and support in every area. Well, as I promised already, I will now switch to the presentation, to the workplace. I started it already in the background. And give me just a second to share the screen. So, Alina, maybe you can quickly give me a short hint and indication if it is visible. Can you see everything?
Yes, it is.
Yeah. Okay. So we are in the workbench. The workbench is located in my browser, has functionality similar to use cases that you are used to the workplace. And iTAC.CATi is now a new item in the menu structure. And when you open it, we are starting with this first initial tool set, which is validating our documentation. So a typical question could be either I'm not sure how to configure things, how to set up things, but looking into the area of development. Nowadays, Copilot, ChatGPT, and all these open AI tools are used also to support development. And maybe at the beginning of a new project, an implementation engineer wants to start coding and is looking for a special feature. That might be, from your point of view, an easy thing, but shall give you at least an impression how you can work with it. So I want to check the serial number status with an API. So I could ask the system, how can I check the serial number status using IMS API? Now, the system is checking all the documentation available across our uploaded content. And it is checking it, finding the correct function declaration. So with some context out of our documentation, the IMS API declaration that would be necessary to do it, TR check serial number state, all the in and out parameters that are necessary, input keys, output keys, and that is what I tried also to show you here with a short explanation how you would use it in your code. So when you have a different coding, you could also say, I do not want to use Java code or whatever code, please show it in my dedicated language. And this is something that helps us to speed up. And here's also the link to the documentation when you want to read the context of the PDF a little bit more detailed. So this would be a very easy approach how to use this functionality. And as mentioned before, in terms of how do I train people, how do I train someone who is maybe new to this content? I started in February this year again at the company, and there were some new colleagues also starting and using this tool, and said it is a real good help to understand what is necessary to be done, where to find things, and how to do things. So it's a really good help. Another thing was this additional element where said we are requesting data using our views, and we are using this MCP interface. And I just have there some prepared showcases of which products are produced right now, product by name, and show them in the table. So this is the repetition of the question, this is the location where it is retrieved from. So it is, as I said, a view. You can see it here in this row from view work order with the work group and with the work clausel and the group parameters. And we see the table with the part numbers that are produced, a short chart underneath. And just done with a second without the need to have the request in our workplace or workbench. So you can form nearly every request that you want to do and get the answer. So the limit is, as I said, at the moment, the IMS view declaration, the view declaration that customers typically are using already for the creation of reports. And we are extracting the data out of it, and we lay this knowledge graph above of it and give you then the answers that you expect. And when the answer is not formed in a way that you wanted to have, you can reformulate your query or just ask us to generate additional knowledge graphs to be more precise and faster in your answers. So that's the last slide from my side, and I would like to give back to Alina so that Heike can switch to her presentation.
Yes.
Thank you.
So thank you, Andreas, for the presentation. And I will now pass over to Heike, who will start with her presentation ready for APS.
Yes. So can everybody be heard? Very good. The quality is
yes.
fine.
Yeah.
So I already shared my screen. Thank you, Andreas, for also the introduction of DUALIS and our capabilities of planning, so strategic and operative planning. Yeah, like introduced, my name is Heike Wilson. I'm the Managing Director of DUALIS GmbH IT Solution in Dresden. And yes, I will take you on the path of APS in the next about 30-35 minutes. Maybe if I gather some time for the end, I also can have a little look and feel of the product itself. Mainly, I will focus still on the questions about how to get ready for an APS project. We feel like the demand, especially in the planning area, is getting bigger all the time. And but there are also a lot of still a lot of questions out there. Why do I need an APS system, advanced planning scheduling? What does this mean, especially the advanced? What can I expect from a product like that? How does it differentiate in my whole IT production ecosystems where you maybe as customers already have ERP, MES available? So how does this fit in there? Also a couple of challenges which we saw in successful projects where companies have been started off with. Requirements, lots of experience from the project. So we want to actually get you ready for a project with us to implement an APS system. And like I mentioned, maybe a little look and feel at the end if I gather some time. So the first question, what does this advanced means? I mean, lots of customers already have an ERP system or an MES system, a MOM system. And now is the question, usually, what can I expect from a planning system? What is it, which benefits gives it to me? In addition, what I have already available in ERP. And there is unfortunately no really definition of advanced planning scheduling systems. But over the years, I would say that developed core functionalities, which I would think is should be in any APS system available. And of course, we offer this also in our product Gantt. So first of all, and that's the main success factor and also efficiency factor, is that an APS system should offer you an algorithmic planning. So this is basically the advance. Before we had maybe a heuristic or like a sequence scheduling, but now we want to have optimization-based planning. with goals, with optimization goals, which you can basically weight depending on your situation in the factory, which can also change. You want to do scenario simulation, so it should be a fast automated planning. A second point, definitely, which also was created in the former times by us, is the multi-resource planning. So what does this mean? You don't want to actually only schedule your orders on machines. An APS system, a modern, innovative APS system, should be able to also schedule depending resources. So today the machine is available, but do you have enough workers available with the right skills to actually operate or set up the machines? As well as the tools. You know, often in specific processes like molding, for instance, you need tools availability and tool scheduling. Otherwise, you don't get a realistic schedule. So you see there's a lot of dependence, and it, last but not least, the material. So an advanced planning and scheduling system should be able to take all those 4 resources in account to create a feasible schedule. Of course, transparency. You can fight and discuss what's the best way of displaying a nice Gantt chart, or what kind of other tables are available to present the result from the scheduling. We feel like that you should be able also in real time to make manual changes which have an impact on your plan, and the APS should show you very transparent and very efficient what are those impacts and what are the results for your whole order system, order network. So last but not least, I mentioned already the material requirement planning, which is usually a functionality of the ERP system. I will actually mention this a little bit later as well. But from the planning point of view, it's very important that material availability is also taken in account, because otherwise you have a parallel system and there will be a material supply will be changed in the ERP system. If you don't have a connection and the APS system can't get this information or can't work with this information, you will have also an unrealistic plan which gets created. So these are 4 very important core functionalities which we feel like should be defined for the advanced in planning and scheduling. And of course, we have implemented those as well. So all of those is, it seems like the APS is a very dynamic and very efficient system. So here you can see basically a planner who obviously doesn't use a advanced planning and scheduling system. Why? That's the big question, because there's a dilemma. Usually the ERP systems have core functionality of the orders, master data, and so on. And sometimes they also offer, I would say, like a kind of more roughly managing planning. And on the other hand side, in the shop floor, there's a big demand to get like the dynamics which you have in your operative plan handled. So there are downtimes, there are workers missing, and this is usually handled today outside the systems, often still in Excel spreadsheets, own developments, own little silo applications. But still, the planners are the ones which I see often are in this dilemma, because they have to argument to their management, to their bosses, why should we actually add now another additional system into the IT infrastructure? What are the reasons for that, and how can you argument? And that's what I would like to actually introduce. So you learn now why is APS a very efficient and also a system which will make you better in your daily operations. For this, we need to understand what's the borders of each system. So usually the companies I mentioned that have an ERP system, enterprise resource planning, maybe also an MES system, but we want to focus on the ERP system, which is implemented. And now this ERP system has functionalities, and we want to compare and want to see where APS is actually advancing the functionalities or makes a real difference. first of all, and this is all of you will know that probably, the ERP system uses unlimited capacities for scheduling. What does this mean? So the order scheduling or the demand scheduling uses the capabilities or the capacities of resources, but in a short term, since you don't work with shift modules or you have maintenance plans and so on, you will get an unrealistic plan. The APS system uses shift models, uses those information of the capacities for all resources, or 4 resources I mentioned. So there are limited capacities, which gets the plan more realistic. Consistency in planning. The ERP system is rather consistent system of master data, all the static data is implemented. But in your shop floor, you need agility, you need flexibility, and you need the possibility to reschedule with lots of different, very short-term information. So the ERP system has more a rough resource allocation. So based on the planning against the unlimited capacities, you only get rough assignment for resources. Often you use only like a pool of machines, for instance, because you don't need more data and information. That's also right. I don't want to say that is not the right approach of an ERP system, but it's not enough in order to support short-term scheduling. The APS system has a lot of possibilities to model special constraints, needs to be very flexible to model those constraints based on the master data, which are imported from the ERP system. So we need to have a very flexible, very parameterizable system, which can be parameterized to the needs of every company. And in planning, everybody is different. There's not, like a kind of a template you can use for everybody. We need to understand what the system needs to understand, what are the constraints of the operating planning. And then we have to try to what we call model this in the system without to use a lot of flag programming or no programming, basically. So this is why, based on the functionality of the leading and the APS system, we can define like this is very important. Why makes it sense to add an APS system to your IT environment. And when we look at today's, I mentioned that already, today's situation, often we have the situation that you have a ERP system and maybe also like in the shop floor area, you have feedback, but in between you get the data out. And I know a lot of planners nowadays which use the data and manipulate them manually, like I mentioned, maybe in Excel or in other systems in order to get the right order backlog to the shop floor make an information and adapt the plan to the short-term information. And this is what we want to close. So the gap, which we just showed, is going to be adjusted and closed by the APS. So the planning and optimization based on the data of the ERP, all the constraints, the material availability, resource availability, shift models, and all the short-term informations will be scheduled in the APS, and then there will be a bidirectional way to communicate with the shop floor. So it is a system basically which flows, information should flow from one system to another seamlessly. Well, we have a little bit of interactive planned here, so it does not get, I'm just going to go back maybe, that's back, let's go here. So my colleague Daniel will open a little questionnaire, so because it's the afternoon and we want to actually have a little bit of interaction here. So Daniel, would you actually ask our audience here, based on this information, what I mentioned, so how the systems set up, would you say already that, are you using already a system which closes this gap, or you still are outside of the systems, manually on, using planning, Excel or manual tools? So this is the question. There should be a poll available for you while I am continuing. I think this should be possible in parallel. So maybe the colleagues can give me a little sign if the poll was activated. I don't know if there's maybe how many planners we have in the call, but also managers are invited to answer that question.
It was already activated, Heike, so people are still answering it.
Okay, very good. So you can answer it, and I'm continuing here. So I would be very interested to know what's your situation here. So one of the main points, and what might make sense to look at, is what were the challenges customers we work with who implemented an APS system with us, where was their starting point? And there's a lot of points you probably know also from your daily work, which makes it quite hard and quite rough to get the right plan out there and to be efficient. So some of them, I want to actually explain a little bit detail. One is right now very much important because there's a lot of transparency coming with an APS system. It's not like the goal which gets the financial or can be financially weighted, but a lot of customers say there's lots of communications, daily calls, daily meetings. The question, what would be happen when we move an order from one machine to another, or delay, or even like change the priority of orders. So this is a very big part of an APS usage, the transparency, which everybody has. So it's not just the planner. You can, take implement the sales people. You can say to your management. You can have a on-click transparency look into what's the situation right now and planning on and in your order sequence. Also, the optimization, which is done usually today local. So what do I mean? People or the planners really do try to do a good job nowadays down on the shop floor. They are trying their best. Often, like people, the operators, like decide themselves what kind of sequence they do at the machine level. But what is missing? Missing is the all overview of the entire work plan, of the entire company, of the entire work process, which are maybe not in the view, or there is no possibility to look at them. So with an APS, since you have a central view on all the departments, you can actually optimize that. And the local optimization will still happen, maybe once in a while, because operative is a very, you have short-term possibilities to also change sequences. But on the overall, this is the plan which brings us overall beneficial. Yeah, the communication I mentioned already, which is also very important, we will have, and that's the application also Andreas explained, there will be more and more automation since we're not going to have enough skilled workers available. So this is also some demographic changes going on, which we have to make sure, or we want to make sure that our customers are prepared and they can use like agents, they can use the experience of algorithms and use this in order to give also not so much trained people the chance to create, for instance, in our topic, a valid and optimized plan. So there are a lot of challenges which can be changed. I mean, it's not like something what has to be worked on, of course, but there's only some challenges which our customers started off with before using an APS system. There are more challenges coming also from our economic change, for instance, like more individualized product. Of course, there's a lot of questions, when you have a high variancy, individualized products, small batch sizes, you need to know, especially like in a very high setup environment, what would be the optimal sequence to actually reduce those setup times. And yeah, this can't be just, like I mentioned, already only done by departments, like single departments. You have to have an overlook over all processes. So shorter response times. I don't know if anybody of you already thought to like simulate order requests. So capable to promise. When can I deliver? It will be in the future definitely that the ones who actually are the fastest answering like a request have the biggest chances to get the production order or the order in-house. So something like that, that's an easy way in an implemented APS system to be solved. We also have a very high dynamic going on. We just all think about this tanker like getting stuck in the Suez Canal channel, which was a big interruption of the worldwide supply chains. And there was a big question, what's going to happen and what can we do? And of course, that's an extreme event, but yeah, in a smaller environment, there's a lot of like dynamics, also material supply, yeah, orders coming late, deliveries coming late. So you need to be able to react very fast and to know what's going on, and in a like seamless flow, basically from the ERP down to the shop floor. Yeah, so based on the challenges you have seen, Daniel, I would like to ask you to open up the next poll. So it would be interesting for us to know what's your situation? Have you ever focused or learned challenges which I mentioned? We have put down the most, the most often mentioned challenges. So if you want, you can tell us what's your situation? What is your main pain, basically? And yeah, so while you're answering that poll, I think that probably worked like the first one. I can continue here with the next topic. So since now we actually have said, so where do we come from? What's the introduction of an APS system, the functionality of an APS system? What is the advanced means? What's the organization or the goal we close? And what could be challenges you are be able to solve with an APS system? And now you made a decision, you want to actually start a project, and you want to get this add-on running in the MES. So what would be a good preparation in order to be successful? So from our point of view, I can share some very important learnings, and I hope this is something you can take from my presentation. So first of all, algorithmic planning, I have to say, is very depending on the right data. So that's why you see on the left, master data, master data, master data. The quality of the data is very important. I would say that lots of companies are already working on this. So we see more and more better databases, more accurate databases. So the implementation, of course, gets then also easier for us. Second, team composition. So how does the team should be set up? How do you want to take your team into the project? Involve all the interactive parties and like planners should be there giving their feedback, since we are trying to model the knowledge from their brains, from their heads into the system. We need them on the table right from the beginning. And also system requirements. We can't, or we want to help and implement, of course, a fully functional APS system, but we have to start somewhere. And our recommendations definitely is to start with the sweet spots. So usually I'm asking, what is your main pains? Let's talk about the 3 main factors which would be helpful to get implemented. And very helpful is also to do concept POC, where we get everybody on the table, and we describe the use cases. We can check what's available, from the data side to support those use cases in planning. We can actually do a little bit of training already. How is the look and feel? How would be the processes, the planning processes change using an APS system like Gunplan and and so on. Yeah, I forgot on the left side for the data requirements. Of course, it's something we offer as well. It's kind of a proof of data. So we have like a kind of an pre-sales situation. Companies who are which are interested to learn more about their data, about the possibilities of an APS system, they can actually fill in data in like a kind of an Excel sheet, which represents like the main data for planning. And from there, we can actually import very fast into our system, and we can show what's the situation, which data is maybe missing, what would be the outcome, planning outcome results when you use like the data which is available right now. So those are main factors from our point which you should think about before you start start a project. So if you have done then, let's say, a POC and we are going into a implementation project, what would be also think of important preparations, or let's say also organization points to start off with. So first of all, of course, a good preparation using expert knowledge. I mean, there are maybe systems you can also implement yourself, but it should be like a kind of a support from experts, or also in the specification phase, to tell you where to start and what to concentrate on. Let's define the use cases together, and also the test I mentioned already in the POC is very useful in order also to learn about borders. So an APS system will not solve all the issues. There's a lot also like which still should be handled either from data or from the data side, should be handled beforehand, or there are also borders in the planning results, or you need to start on a kind of manual way and can during the project or afterwards you can improve and get more automatic all the time. Team is crucial, which I mentioned also. Everybody should be on the table, which has to valid information for the project planners, IT, of course. Maybe also like sometimes I have learned also like people who can from the outside moderate and moderate this kind of mind shift also about how everybody profits from the results, since like I mentioned already, also sales can profit, or management can profit, or even bookkeeping departments can profit from this information, but also the input of the data. Everybody should know, why do I have to be correct with data implementation in order to feed the system. Continuous support and initial validation and integration phase, that's one of the most important steps in a project. So I say nowadays, like for instance, in our integration with the iTAC Mom Suite, there is no interfacing. We are seamlessly integrated, so there's no integration work to do. But a lot of work to do is in the validation part. So the data flows into Gunplan, and then we have one important phase where we look at the results. So the planner looks together with an expert and ask questions. What's the order? Why is the order planned on this machine? And why is it not on, or why is the setup sequence looking like this? So somebody has to look and has to have the time to look with us together to validate the plan in order to get, you remember, more and more to that phase. You can use the APS and an automatic modus. Change management, I mentioned already. I also mentioned get everyone on board. So team is crucial, and the important people should work together. And also one important thing, in order to get more acceptance also for the product, to get as best feedback you can get, concentrate on the low-hanging fruits and the results. So I mentioned already like transparency, for instance. often, companies don't even know what's their, let's say, backlog of orders. So if they use Scamper the first time, they will be first time seeing, what kind of I call it the little tsunami wave, which kind of backlog has been produced over the last months, since maybe you planned 5 orders a day and you only finished 3. So tomorrow you have those additional orders, and this is kind of building up. And usually companies don't know exactly how big this backlog is. So this transparency with the first click, it's a very low-hanging fruit. And it makes transparent where you really stand in your operative shop floor. So important to concentrate, to define low-hanging fruits in order also to say, okay, this is something from results we can show very fast. There are really important things to do, and there are don'ts, so important things not to do. And there are also learnings which we have found over the last over 500 projects we have done. What are the most important learnings we have? What was our taking away here? We can't really do everything at once. So based on the POC, we should concentrate on a couple of use cases, and most important use cases. But there can be also unrealistic expectations or too much expectations at once. And this is it's not very helpful, because if you decide to implement an API system, you should actually get your key users on board, which know or understand the model, understand the working of the optimization, the parameters. And then you can actually constantly, even after the go live, you can constantly improve those parameters and model different situations. But you should not think the APS is solving every issue. You also have the acceptance I mentioned already. So there should be the possibility to get off all existing manual systems as fast as possible, which I always say to the managers, that there will be, there often is this kind of fallback situation, working beside the system, working still in Excel to make sure everything is right. But that doesn't help anybody. You need to actually start using the API system, even it's unfamiliar, it's new, in order to get really into the product and with all the powerful functions which are there. And also, which we found is very important, which in bigger projects we do have those communication rounds, Lenkungsausschüsse, where we are, on each level of the project, we will discuss how's the progress, how is everybody happy with the progress, is there any backlogs, anything what's not working. But always the project leaders should have the idea, or also the support from the management, if there's something not working, somebody not delivering, that they have the feeling they can go and report and get this support from their management in order to fulfill the goals for the project. The introduction on site I missed, but this is also important that, of course, there will be the project we support, of course, also on site, but the people should be able to also learn from others. So we offer also different exchange formats where our customers can come together and learn how other customers maybe model or work on different constraints in different situations. So that's very important. There are a lot of more. Of course, we can't really mention all, but I think the most important we have here on the table. But there will be also the possibility to discuss further, maybe in projects with you. Of course, it's important also when you actually started a project. Now we have the learnings, what should be prepared, what is, you have taken in account, what can go wrong, and what should be concentrated in a project. But also a lot of documentation also comes from what be the success of using APS system, which is a big, of course, a counterpart. So, of course, I mentioned already transparency, like up to 100%. So this is like by the click, by looking first time on the data which gets imported to see what's the situation. Of course, the time saving. We don't say usually that we actually save on the head count, but we say your time on planning purpose, planning function is rapidly decreasing. So up to 50% of time saving. I mean, you can do more planning then. You can actually do scenario simulation. You can try to optimize the planning. Of course, this is all because the system should be automatic planning, should do automatic planning and be very efficient. But you also can simulate or reschedule very fast. So usually when you start in the morning with the plan and some changes are coming and you had to do it manually, you start it all over again and it takes a lot of time. So this definitely is a point which gets very good grades to increase. Yeah, the efficiency, of course, if you have better scheduling, if you have better sequences, there is the possibility to reduce setup times and therefore increase the possible outcome. And also the cost savings, which I always say is do the other ones first. So use first transparency, use first your more time on maybe data optimization and faster planning. But at the end, you also, when you use or if you use the costs in your data model, in your master data, like machine costs, setup costs, penalty costs, even though you can have a big cost saving there as well. Yeah, before I actually back here for one, there's our last poll. So if you if you want, Daniel can open the last poll here after the all you got to know about the possibilities of an APS system. What would you say? Would you be interested in this as an additional add-on to your MES ERP system? Or is it something you say, well, that's not, doesn't solve our issues in planning, so it would be nice to get your answers. And before I actually get into one of our main future topics, predictive planning, since I have a little bit more time, I would like to give you a little look and feel on the product. And I will switch over. I opened Ganplan already. So this is a little bit of the look and feel after a lot of theoretical information. I just want to show you a little bit of the functionality which I mentioned, which is very important for the APS. So this is typical our Gantt chart where you can see the orders. All the colored columns are orders. And you go over it here, you can see basically the information to the orders. You see basically the gray areas. This is exactly the limited capacity, which I mentioned. So this is basically in the machine level. Sunday, you don't have any available capacity. If we look, for instance, on the worker sketches, you can see much more detailed capacity. For instance, early shift or late shift or night shift, which also is important when you want to schedule workers. So this was the second information I gave you, that is not just the machine level we schedule. We can also, it's important to schedule also workers, maybe worker pools for different functionalities and also with different skills, and also tools, which you can see here. different tools for different operations, which are also native scheduled. So it's not like a kind of a virtual resource. It's really a resource which can maybe come from a maintenance, from a tool system. Those tools can have also maintenance, which is usually the standard. So this is something as well I showed you. Now I want to, of course, quickly show you the optimization, so the automatic planning, which is the most powerful function, of course, of the APS. So that's why I'm going to start here in my production plan, which I started off with. I will start the automatic planning function, and based on my scenario, on all the feedback, on more available capacities, new orders, finished orders, all the information gets pulled together, and I created in the fast 30 seconds or 20 seconds a new automatic plan which focuses on the different new situations. And this is what I mentioned, that it should be like all the impacts you have should be countable. So what you can see in the bottom now is like a compare based on now the planning, the plan I just created in comparison to your production plan, which was, my production plan, which was now running. And you can see that we have like a kind of a more delay situation, just 4 orders delayed, but a little bit of an not so good development. But also on the cost side, you can see the comparison, which is important. So you see basically with each planning step what has been changed. So that was one of the function as well as mentioned. And also if you want to use manual scheduling, you can define what are the functionalities. Functionalities you want to, constraints which you want to, take in account when you reschedule manually, for instance. What is our goal? We want to show very fast what's going on. So we have a lot of nice, for instance, nice, FAB schemes here. I will just show, for instance, let me go on the delay. That's the typical traffic light system. So that means you can actually either use the standard FAB schemes, or you go basically in the your own FAB schemes you can define, and each function parameter can represent a color. So in that case here for the traffic light, of course, the red ones are, you see in one click which orders are delayed, the green ones are on time, and the orange ones have a different specific parameterization. So this is what we want to do. We want to actually show in very transparent, very efficient, by click, what is the main important fact, where do you have to actually work, what do you have to work on, what do you have to improve in your plan, and that what actually an APS should be able to show very fast. So I would actually say that was a little look and feel. I can actually now switch back to my presentation. We're a little bit before our time schedule. I don't know, we can actually have, maybe if you want, we can have some questions now, or what?
Yes, we actually have a question from the audience.
Okay, very nice.
So one question is, can DUALIS APS also be used in different environment than iTAC MOM with other MES systems?
Yes, we can. That's also, of course, the integration is a topic then. We need to know which system it is, but there's definitely also, but since it is a game plan as a single product, we also can use it with other ERP and MES systems, yes.
Mm-hmm. Thank you. So far, we don't have any further questions, but we can quickly take a look at the polls that we did, because I think this is also nice. Interesting for you and the audience. So the first question you asked was, have you already moved beyond Excel for your production planning using a software system? And 59% say yes, so they are using a planning software. And 41% say no. So there's still quite some potential, I would say. And then
which is also fitting our our experience from the market. Yes.
Okay. And the biggest challenge in the audience was limited visibility into planning and production.
Yeah.
Maybe also something you can recall. And a second biggest challenge was spending too much time on planning tasks. So this, also something an APS system can help then, right?
Yeah, I guess we have quite some planners here in the audience. Usually it's always the second place is a lot of, depending between the time, but also there is the challenge of, I think, can you just open it? I think it's also, what was time saving usually? That's when when we have more planners in the audience, but that's, probably the result there. Because there's a management question as well, which comes usually up if there's more management in our webcasts.
Yeah. And then the last question, would exploring an APS solution make sense for your business? And most of the members from the audience say yes, 58% actually. Only 8% said no, and 33% maybe.
Maybe, yeah. Well, I think, that's what we experience, that a lot of demand is in the market. It's a very important topic to actually have a good planning, because this is where you are, I say always when you plan better, you produce better. So this is where you actually have to start. It's not an easy topic, of course. I mean, there is work involved, but we have a lot of good experience and very good results in projects. And we'll be happy to have the people here also be interested on board and discuss further. But now I just want to give a little bit of a teaser what is our future in future with AI, which my colleague Ferdi will introduce in a couple of minutes. So right now, when you use an APS system, your plans are usually deterministic. So what does this mean? You know right now what's the situation. I showed you the Gantt chart, and let's say you have a downtime on a machine. This is now, you experience this now, you put it to the system now, and of course then you reschedule, but with that information in the system in that minute. And what we do now is that away from that deterministic focus, we will, or we have already implemented our Gantt plan analytics. And first of all, in this add-on, we collect all the data from the past. So we collect all the feedback data and store that data in a service, which is done, and this will Ferdi show. Our goal is to have the information based on that analytics service to predict the future and planning. And now I don't want to tell anything more, but it's very important because then the plan would be more robust, would be even more acceptable. And probably the rescheduling, if we can make that, if we can integrate that historic data, the rescheduling will be less significant and will have less impact, because then we can predict from the past to the future. And that's our goal, for the next development steps. And Ferdi, the stage, I would say, is yours. Alina, I took your moderation.
That's all right. That's all right. You made the perfect transition.
So, all right. Then, Ferdi, stage is yours. And thanks for listening. And
thank you, Heike. And Ferdi, you can share your screen if you like, and then just start your presentation.
Yeah, no problem. Just one sec, maybe test. Can everyone see or hear me?
Yes.
Perfect. Yeah, then thanks, Heike, for the kindly introduction as well. The topic APS and the future of our Gantt plan APS. First of all, welcome to the Smart Factory Summit from my side, and of course, welcome to my presentation. My name is Fernand Zule. I'm a data scientist here in Dresden at the DUALIS GmbH IT solution. And today I want to talk about predictive planning with AI, how to get more realistic processing times and accurate deliveries. So I want to get one step deeper as Heike into the future. So let me show you today's roadmap. First of all, I want to talk about the pain points nowadays. So what are the problems in our production area, or to be more detailed in the scheduling. Then I want to come up with the solution. So the solution with predictive planning. And this section is divided into 3 parts. First of all, creating the database. So this is the first step. It's more or less the requirement to solve these problems with data. And then I want to show you the first use case, the more realistic processing times. And after this, the second and last use case, the more reliable delivery dates. In the end, I want to sum all up and give a short outlook. And yeah, with this in mind, let's start by looking where most planners are today. What's the status quo with deterministic master data? I think Heike already showed you the look and feel of our Gantt plan APS, but here in one slide, you can see the Gantt chart, so the production plan on the right-hand side. And APS stands for Advanced Planning and Scheduling. I want to try to summarize it in one sentence. It's a software which enables you to plan all orders based on available resources and capacities while regarding both costs and capacity requirements. So overall, it's a very nice software to enables the manufacturers to boost their efficiency, even in very complex manufacturer areas. The status quo, like maybe Heike already said, the APS system only looks into the future, and the production plan is calculated on deterministic data. We can say, and that's quite good, that the solution at the moment of planning is quite perfect, but maybe 2 hours later or maybe 1 day later, the plan starts to fall apart and we have some deviations. What are the challenges, or why does this happen? We have 2 challenges. First of all, we have external disturbance variables. So, for example, we have a machine breakdown. The machine 05024 screwed up. We can't use this capacity anymore. And yeah, we have to reschedule. We have to use alternative work centers in this case. So this is the first problem. And the second problem is because we are modeling our production landscape, our assumptions are not 100% realistic. So for example, Christoph Stutt is a little bit tired in the evening and needs more time, and his scheduled operation is too slow. So he needs more time. These 2 challenges result in a deviation between the planning result and the reality. Furthermore, we can say that the adherence to the delivery dates will decrease and the costs will increase because we have to reschedule all the time. So far we've seen what are the problems, why deterministic data is driving reactive planning, but what exactly can't you see today? So let's put your APS, I would say, in a reality check. First, let's be honest, today it's quite difficult to tell where and when your production deviates from the plan, or how much and how quickly does your plan change, and even the other questions on the left-hand side. We want to solve or answer these questions, and for this, we want to collect lots of data. We want to collect from the top level, so from the ERP system or from the MES system, like the iTAC software group, or from Accevo, or from the most detailed level from the APS system, like from the Gantt plan from DUALIS. We want to collect all of this data in one database so that we can try to answer these questions. And here in this case with the new module Gantt plan Analytics. Gantt plan Analytics can save all planning data, and with this data, we can compare planned and realized production plans. Furthermore, if we have the data from the shop floor and the planning data from the APS, we can analyze the progress of every production order. With this data and the new features nowadays called AI, we can also enable some use cases like the forecasts of peace times and the forecast of due dates. And overall, this module Gantt plan Analytics unleashes the full potential of your production landscape through precise analytics and AI-supported forecasts. I have to mention here one thing, because when I say we want to collect data, then of course there's a connected shop floor required. But if personal data is collected, just be aware of privacy concerns, because we have kind of a trade-off between privacy and accuracy. We want very detailed confirmation, but maybe this is not the best for the privacy. So yeah, just be aware here. Before we dive deep into the AI-driven methods themselves, yeah, first talk about the undeniable requirement, the clean structured data foundation, so the database. So let's see how we can build this. Nowadays, we have currently still too little use of the historical data, but I already said this is the requirement for the future methods. The solution here is quite easy. We want to store all planning results and key figures. And with this, we can record the production progress and also all the required resources. You can see on the right-hand side our report called Result Information Progress. And this is quite easy because at the top you have our metrics, our most important KPIs. And at the bottom you have the related costs. Maybe what you can see is that in July we have a drop in the early production orders. Then we bought a new resource, and maybe the early production orders increase over the time again. So this report shows the progress of the planning results for a selected period. And the payoff is quite huge because now you can check the consistency of the plans. So it's kind of a plan realization. And furthermore, you can analyze the planning quality over the time. And with this, you can now derive a planning horizon based on data rather than just a good guess. So if everything is set up and our table is set, we have every data in one place. So the planning data from the APS or MES and also the shop floor data, like the confirmations. What can we do with all of this? Imagine the following scenario. Can we identify resource-based delays and directly adjust speed factors and then reschedule on the fly? So like Heike already showed you, here is our Gunplan APS, and I think most of the planner knows what here is shown, but you can see all the planned resources, all the scheduled operations in the Gantt chart, and you can move around and see everything. And now you can use a new color scheme. The color scheme is under the production order section, under the default color schemes, and it's called duration analysis activities. If I select now this new color scheme, and then all the scheduled operations are colored. And what happens here in the background? An AI model is asked to predict a more realistic duration for this scheduled operation. So the AI model first is trained on lots of confirmation data, and then all the influencing variables like the planned work center, the planned worker, the timestamp, so maybe the shift, and also the operation type is influencing the output. And if there is now a deviation between the AI prediction and the, I would say, old way to calculate the deterministic master data, then the operation is colored. And based on the historical data, we can now see here are some deviations. And in simple words, what means this operation will take more time based on the historical data. So we will be here slower. On the other hand, if we have blue operations, this means, okay, we will be faster here based on the historical data. So it's easy to see if there are some expected deviations. If everything is green, then it means, okay, our confirmations matches the reality or the plan. We have no deviation, and yeah, everything is fine. So I would say everyone can see that something is kind of strange here because the work center 03022 has very many wet operations. So now we can have a detailed look into this work center. For this, we can use also a new report. This is called Verlauf Stückzeiten Ressourcen. Right now, it's only available in German. But what you can see here, first of all, you can select a period you want to analyze. So yeah, maybe the last year. And then you can select the resource, in this case, the Strange Work Center with IB 03022. And what you can see now is at the top, you have the progress, and at the bottom, you have the distribution of the ratio between actual and planned peacetime. So at the top, first of all, every green point or bullet represents a historical representation of an activity. And we want to hit the vertical horizontal dashed line with 100% because then we have no deviation. What we can see here is that we have a big deviation. We are at around 200%. The black line is just a moving average to smooth the data, I would say, and kick out outliers. So it's easier to see the trend. You have an alternative representation of the same data at the bottom. So in this case, you have a distribution, to be more precise, a histogram. And here, as well, we want to hit the vertical line in this case at 100%, but now we are, again at 190, 200% deviation. So we are too slow. Quite easy to see in this plots, but what can we do now? We jump directly into the master data of this work center. We can see it's the critical one, and we can see, okay, here was a speed factor from 100%. This was too fast, so now we can change it to 50% maybe. And now we solve this problem because all operations scheduled on this operation on this work center will be scheduled with the double amount of time, so twice as long. Quite easy to solve here. To sum this use case up in just one slide, we have the challenge that we are assuming master data, which is rigid and possibly error prone. And the solution here is we want to have an analysis of causal relationships between the influencing variables, so the input features like worker, work center, timestamp, and so on, and the real actual operation duration. You can see on the right-hand side a chart of a specific operation. This is real data. And you can see the relative deviation of process duration over the time. So the x-axis is the time, the y-axis is the relative deviation. If we are underneath the blue line, so we have a negative value, then we are too fast. And if we are above the line, then we are too slow. What we can see here is over the years, also colored nicely, is the target time. And over the years, the target time is adjusted. So from maybe a test case with 2,000 minutes, then 1,500 minutes to just 500 minutes. And what everyone should see, and it's quite clear, the year 2020 was the best. We should stay there and use this target time because here the target time matches the reality and target equals actual, because we have a deviation round about 0%. This is quite easy here to see, but ask yourself, how do you factor in a machine type, operator skill, batch sizes, setup sequences, or even material quality, and so on? Because those dependencies form nonlinear patterns, which are far beyond from a two-dimensional plot like this one. So that's exactly the point where our AI model is so powerful, because this AI model detects causal links in the data and predicts cycle times no human chart could match. In easy words, or in an easy scheme, I would say we have our input feature set, in this case, our work center, our operation, our shift, and so on. We feed this to the AI model, and the AI model will predict a more realistic duration based on this historical data or based on this input. So the advantages here, our prediction accuracy will increase because now we have a dynamic adjustment of the planned duration. And of course, if we have a better prediction, then our rescheduling effort will decrease and our scheduling accuracy will increase again. There are many AI models. I don't want to talk here in a very detailed way, but this is the use case in just one slide. So these refined and more realistic operation times feed directly into the more reliable delivery dates. So here we are at the second use case. Can AI provide more realistic delivery dates by analyzing resource availability and maybe also workload patterns? So again, our delivery date, which is calculated analytically, is quite good at the moment of planning, but it bounces around because we have maybe a rush order, a very important rush order. We have machine breakdowns or illnesses. So this is the reason why our delivery date can bounce around. The solution here again, we want to derive process data from the historical actual data using AI. And we want to have a more realistic estimation of the delivery date and also of the capacity utilization. Again, in an easy way to show, we have an artificial intelligence model here, a neural network, and a lot of data as our input. So again, our worker resource shift and maybe the utilization, and it's modeled in an easy way as the count of production orders in our system as an input. And now the AI model will predict a delivery date, in this case as a distribution. I mentioned this because it's very important and it has some big advantages I will explain in a minute. Overall, this use case will increase the adherence of the delivery dates and the planning security. So why is the distribution so cool, or what are the big benefits of this? Here you can see the output of the AI model for one specific production order. So this is the output of the AI model, and you can see it's a cumulative probability. And on the x-axis, you have the delivery days. On the y-axis, you have the probability. Because it's data from a real-world example, this production order had also a real date, a real shipment date, real delivery date. And in this case, it was 17 days. We have an adjustable safety factor. I will explain in a minute. But the important thing here is we have a best case and a worst case because of this distribution. I want to explain in the chart. We have two colored areas. So first of all, the red area and then the green area. And yeah, we have a best case for the planner because it's quite fast. He can say, okay, with a probability of 30%, that's the reason why it's very risky, I can ship in 12 days. On the other hand, if he is very cautious, he can say, okay, with over 80% probability, I can ship in 22 days. So with this cumulative probability, the big advantage is the user can define their own security or risk preferences. And yeah, maybe the tool or the software should tell a specific value. Then the user set an adjustable safety factor, maybe it's 50%, and then the AI model will also predict a point guess, so just one specific date. In this case, it would be 15 days. So if the user or the planner wants every time more than 50% probability, then it would be here 15 days. So again, the adherence to the delivery dates will increase and planning security as well. We have a, I would say, step-by-step integration plan here. First of all, you have to be very active. You have to ask the AI model for the more realistic date. And yeah, otherwise it won't happen. So you have to be very active. This is the first level. The second level is a warning pop-up if you are in our Gunplan APS. And if there are some big deviations based on the historical data, then there will be a warning pop-up. So maybe the planner can have a look on this specific production order. And the third and I would say most autonomous way is auto scheduling with these new dates. But yeah, that's the last and most autonomous way. So now you're no longer guessing. You have data-proven delivery dates, and let's step one back. Let's step back and summarize all together. And yeah, you can see here the Gunplan Analytics user. So this is a sign we are on the home stretch. Time to recap. Predictive planning. Predictive planning, in other words, is Gunplan Analytics, and in even other words, it's embedding statistical and artificial models directly into your APS system. Nowadays, it's the status quo. We have a good analytical planning with the APS system, but the potential of the historical data is not yet exploited. We have some big advantages of the data collection overall, if it's planning data from the APS, or even if it's the confirmation data from the shop floor. Like I showed you in the two use cases, we can apply patterns from the past to the future to help us, to save costs, because we have less replanning effort, or maybe we have less storage costs. And of course, we can increase the customer satisfaction because now we have more reliable delivery dates. Overall, I would say we can increase the product quality. And some words to Gunplan Analytics. It's of course universal use. Everyone can use it, and it's constantly evolving. The two use cases I showed to you are only the starting point, and further statistical analysis and applications are of course possible. So we are looking into the past to plan the future, and that's my short little presentation. And yeah, maybe there are some questions. I'm happy to take your questions, and thank you very much for your attention.
Yeah, thank you, Ferdi. There are actually some questions I can ask you from the audience. So first question would be, can you also take and you can also see them yourself in the Q&A button. Can you also take restrictions into account through order networks as predecessor and successor relationships, or that an order cannot be scheduled if the required equipment is already scheduled for another order?
Also, I searched the question on my second screen, so I didn't get it in a complete way.
Can you see it?
No, not really. I just see the polls.
When you click Q&A.
Okay, here's a banner. I can't see.
It should be right next to the chat Q&A.
Yes.
Okay. Maybe I can't see it. And now. Just give me a sec. Now I can see.
Good.
So which question was it?
It's from, can you also take restrictions into account?
To say restrictions, I would say yes. In a short way, preprocessor are also possible, but we have just here a starting point with easy models, and I would say a default pipeline. I hope this answered the question. I'm still searching.
Heike, do you have something to add? Or?
Yes, I mean, there's one of the biggest also advantages of the APS is that you have those order network relations as a constraint in the model. So everything from bill of material, own produced materials, or like also material in demand can be taken in account. And there are different predecessor and successor relations we can work on. So there's, for instance, one piece flow or overlaps also in the network. We're quite flexible that way. And the second one, order that an order cannot be scheduled. Yeah, of course, that's well, that's the limited capacity. So if you have, let's say, only one machine, one equipment, and then you can only sequence on that equipment, and the capacity. There is a possibility to define different capacity schedule or use different parameters. So there is like the single 1-by-1 order, or you can use parallel capacity. But if you have 1-by-1 capacity chosen, then of course, if there is like a capacity, the equipment assigned, then there needs to be a sequence. You can't overlay the capacity. So that's a hard constraint, basically, which we have to look at the we look at the real situation, and then we model the constraints accordingly in GAN.
Okay. Yeah, I think the person who answered the question got their answer because he already replied. So thanks for that. And then another question would be, how long do you need to collect process time data to define the target process duration?
Maybe I can answer this.
Ferdinand. As long as possible.
This is the easy answer. I would say, more data is even better. But in this case, like I would say, technical answer. But there are some methods like transfer learning and so on that you won't need thousands of cyclic operation calls. But more data is every time better, and I would say around 50 to 100 and more is a good starting point. But more data is every time better.
Okay, all right. So I guess this is it for oh no, we just got another one actually. Let me check. Just now, will there be in future also a chatbot available for APS to help not so experienced users, which is also an interesting question.
Well, the plan is, we're working on it. But it's not so easy for APS, especially when you talk about the planning functionality. What is also possible is like documentation, of course, and or it's a more closer goal. And maybe also questions in a kind of support matter, which we can build up a database there. But the planning logics to have like a really sparing partner to interact with, we all know maybe from ChatGPT. That's a little bit far away. But of course, the agent philosophy is in our minds.
All right, maybe we have time for one more, and then we would move on to the other the other session. And all of the questions who haven't been answered, then we will answer after the session individually, so don't worry. Last question, how many job runs do you need to obtain a reliable distribution for your models? The graphic suggests that it is several hundred.
Maybe the same answer as the question before, the question to the amount of data I need for this use case. In this case, it was around not 100, but maybe, I guess, 50 or 80 again, repetitions per production order or per our feature set, I would say. Here again, the easy answer is more data is better, and you can start with just a small data set, and if the evaluation shows that it's not good enough, then you should wait and collect more data. But I would say the easiest way is to start to collecting data, and then if there's a threshold, you can start with the use case. So
all right, thank you. Okay, then thanks for the presentation, Ferdi, and Heike as well. So like I said, we will answer all of the remaining questions afterwards. And then let's move on to the next topic. Julie is already here with us as well, and she will do her presentation on MSD Control. So Julie, feel free to share your screen and stage is yours.
Thank you, Alina, and thanks for my DUALIS colleagues that just made the last presentation. So first of all, thanks everyone for attending the session. We're going to jump into a completely different subject, MSD Control. So my name is Julie Clich-Dubois, and I'm leading all product management efforts at Cogiscan. So I've worked in a variety of roles at Cogiscan, from software development to support, and now I'm in product management. I'm highly focused on improving the user experience with our products overall, but most importantly, I love to learn more and talk about the electronic manufacturing industry in general. So today we'll jump into a holistic overview of MSD in electronics manufacturing, and I have a lot of interesting information to share with all of you. So without further ado, let's dive into it. So starting with the agenda, I'm going to start with why MSD Control matters. So looking into the risk of improper handling to the adherence of the IP-CJDEC standard. So we're now at the end of 2025, and we've been talking about MSD Control for more than 25 years. So why is that? And why is that still even more relevant today? And then we will jump into what it means to deal with MSDs in production by looking into the full life cycle of MSD components. So why moisture sensitivity matters? So the moisture inside the components become a serious issue during the machine soldering, especially reflow, but also wave and selective soldering. So the high heat causes absorbed moisture to vaporize into steam, and that creates a general internal pressure. So this pressure can result in component damage, including delamination. So the internal layer will separate, surface blistering, as we can see on BGAs, and cracking of the package, which is famously called the popcorn effect. So I've never heard that myself, but apparently when it cracks, it really sounds like popcorn popping. And there's some additional internal risks. So cracked silicon die, broken wire bounds, underside package cracking. So all these micro cracks, they create a path for contamination, so the moisture and the oxygen. So that leads to corrosion of the internal metal structures over time. So some MSD-related damage is visible, for example, the blistering and the cracking, but others are hidden. So the cracked die, broken wire bounds, underside damage that you will not see. So, and even the hidden damage, they often escape visual inspection at the AOI or even manual inspection, and they can also pass electrical testing at the ICT or functional testing. So that's not good. You can't see them. And this will result into latent defects. So damaged parts that seem fine, but will fail in the field later. So what are the consequences for that? So, well, you will have product failures, which you don't want, obviously. Costly warranty claims, so the returns and the replacement, reputation damage for OEMs. So when we think about OEMs in certain safety critical sectors like medical device manufacturing or defense, aerospace, and even some automotive manufacturers, these kind of latent defects are completely unacceptable because they can actually put people's life at risk. So you really don't want that. So why do we hear more and more about MSD control? Well, first of all, there's the miniaturization trend. So components are smaller, thinner, with tighter pitches, and we see that more and more with the surge on AI-related components. So with thinner packages, it will saturate with moisture faster, reducing the safe exposure time. Smaller components are less able to absorb the internal pressure, and it will increase the risk of damage. And tighter pitches will make damage harder to detect, raising the risk of latent defects. So despite the issue, non-porous packaging isn't widely used due to the electrical and thermal performance requirements, and also the trade-offs in material science, because newer material may be even more porous. So what the bottom line is, moisture sensitivity is not going away anytime soon. And the worst part of it, it's actually increasing. And so it's something that electronic manufacturers need to really take seriously. So MSDs vary widely in how long they can be safely exposed to ambient conditions. So it can vary from 1 year to just 24 hours. So to manage this, IPC and JEDEC developed together the MSL classification system for moisture sensitivity level. So each part is assigned a MSL, so from 1 to 6, so 1, 1A, 2, 2A, 3, 4, 5, 6. And you can even create custom levels based on what's a safe floor life, so the exposure time. And it uses a reference environment with a temperature of 30 degrees Celsius and 60% relative humidity. So when we talk about floor life, it represents how long a part can remain outside of dry storage before requiring rebaking or other corrective actions. So most parts will fit into these 8 levels, but some custom moisture sensitivity levels are used for unique components, especially when parts do not fall precisely into the JEDEC-defined moisture sensitivity level. So therefore, manufacturers have to handle some custom levels to better manage these components. And as if it wasn't complicated enough, moisture sensitivity level alone is not enough to determine what is the actual floor life of a component. You also need to consider what is the current relative humidity in the factory, what is the current temperature, what is the package thickness, what is the package type. So the JEDEC standard JSTD 033D includes an extended floor life table combining all these 5 factors. So the table will cross-reference body thickness and package type against the moisture sensitivity level, relative humidity, and temperature. And with that, electronic manufacturers must locate the correct combo in the table. So that means that to know the proper floor life of a given MSD, an electronic manufacturer has to find where it fits in this very large table and apply the correct floor life value out of the, wait for it, 600 possibilities, which is obviously something that's not very easy to manage. So that's why you should leverage an automated intelligence system to help safely use and monitor MSDs in production. So embracing MSD control goes beyond printing labels and baking parts. And I want to take you to the MSD control life cycle journey on your production ecosystem. So managing and controlling MSD properly takes place at every operation and impacts all processes. It requires a holistic ecosystem that tracks the MSD and the PCBA it's placed on as it moves through the process. So it's always challenging to really picture what it means in the day-to-day to manage MSD. And my objective for you today is to provide a big picture of what it involves to jump into the MSD Control journey, and what part of the process plays a role in it. And as I walk you through the process, I will cover some of the most common MSD fun facts and misconceptions. So you will see some polls on your way to keep this presentation a bit interactive. So let's start with fun facts. So within the Cogiscan MSD Control module, we actually have over 20 different configuration available. So that covers multiple options, from automatically opening the moisture barrier bag upon the initialization of the component. What's the baking grace period? What's the minimum remaining floor life to allow sealing the parts in a dry bag, to blocking production when MSD components are not required in the recipe, but they are actually in the machine. So managing MSD Control is not a walk in the park, believe me, and you really need a software that manages it for you. And with our MSD Control module, we really make it easy and reliable for you. And just to complete this fun fact, in fact, MSD Control was the first product ever released by Cogiscan over than 25 years ago. So we have a lot of experience in implementing MSD Control solutions. So let's start our journey at the beginning. Material registration and identification. So without this, well, you cannot control MSD at all in your factories. That's really the first step. It might sound basic, but it's the foundation of establishing a proper MSD control at the factory level. So every container needs to be uniquely identified so that the proper MSD information can be tracked and follow the container as well. So the unique ID itself can come from your MES, like iTAC, for example, your ERP, and even can be generated by the Cogiscan system if you need so. While you may have a unique ID, you might be missing part of the key information. So other than the part number and moisture sensitivity level, you also need the part body thickness and the package type. So especially if it's a BGA or a stacked die. This is required to make sure that the floor life limits or corrective actions such as baking can be properly applied. So just think about the table with the 600 values that you need to pick from, as that's key elements to get the right floor life value. So one thing to know is that it may happen that the supplier label is inconsistent or incomplete. So it's important to make sure you are registering the material with the right information. And if you don't already have a barcode for the unique ID, you can print it from your Cogiscan system on a label that will include important MSD information. Now that our parts are initialized and uniquely identified with the appropriate moisture information, they can be stored either in a moisture barrier bag on the warehousing shelves, or can be stored without a bag in a moisture controlled environment like a storage tower or dry cabinet. So more and more manufacturers are using storage towers to better manage their inventory storage, as well as to improve the efficiency of pulling and kitting components from jobs. So our system integrates automatically with the storage tower software to track the component loading and unloading events directly through the tower's inventory control system. So storage towers are helpful in better managing MSDs and limiting exposure time. You can have a direct integration with kitting to allow just-in-time production. So your jobs are not just sitting around in ambient conditions for too long waiting to be loaded on the line. When you manage an MSD, it's definitely not something you want to do. So we also account for the short duration exposure rule when loading in dry storage and storage towers, meaning that the floor life can be reset when time comes and when applicable. So let's have a poll right now. We have a fun fact. So fact or fiction, can storage towers, can they control MSDs on the line? So is that a fact or fiction? So we will review the answers at the end of the presentation to see if you did good or you still need to know more about MSD control. But the answer is, well, the towers function like dry cabinets and they keep MSDs free of moisture while inside. However, that's a big point, the management of those MSD is a bit limited and the system loses control of the parts once the MSD is outside of the ecosystem. So typically the tower monitors the floor life clock and then prevents a dispensing, kitting of components that are expired. And the expired components can be removed quickly from their stock. However, they are not able to intervene and interlock the line if a MSD gets slowed on the line or expires during production. So this is where a holistic MSD control system is mandatory so you can properly stop the line and make sure you are not using expired material. So now let's move to dry storage and what are the related specificities. So the goal of dry storage is to prevent moisture absorption into MSDs. To properly manage floor life, you need to accurately track when the components enter and exit dry storage and to apply the appropriate floor life rule based on the different variables. So this requires a system that will monitor the scanning and scan out events when the parts are removed from the dry cabinet or returned to the dry cabinet or moisture barrier bags. So that way, it will apply the MSL specific logic, meaning that without a robust tracking system, it's easy for exposure time to be miscalculated or overlooked, and that creates obviously a risk for latent defects due to the unrecognized moisture damages because you don't know that they are expired. So another poll for you, I have a fact or fiction question for you again. So do dry cabinet pause the clock for all MSDs? Do you think it's true or it's a fiction? So think about it for a second, answer the poll. Okay, so you had some time to look into it. You want to know the answer now? Well, in fact, it's fiction. In fact, it's fiction. So it will only stop the clock for a moisture sensitivity level 2, 2A, and 3. So for the MSL 4, 5, 5A, and 6, the clock can only be reset with a proper bake process. So it's not because you put everything into your dry storage that it will stop the clock. And that's something you need to take into account. Now let's cover what happens when the components are on the production area, from the ambient factory tracking to the PCBA tracking, which is key also in MSD management. So first of all, one of the key aspects of the tracking is the factory ambient. So you need to know what's the temperature and the humidity level because it will have an impact on the floor life calculation. So you can decide to manually enter this information in your system, but you can also use environmental sensors to update it to make sure it's always accurate. The remaining floor life clock will start when you open the bag or when you take the part out of the storage tower or dry cabinet. So it will take into account the factory ambient, the JEDEC standard, and the custom MS level table that you've created. So to improve your productivity, I always recommend to set up warning thresholds so you know ahead of time when a component will expire. So you can know, for example, that the component will expire within the next hour, then in 30 minutes, and then it has expired. So that way you will not be taken by surprise when you need to replace a component because it's expired and you need to bake it. So you can have a PC close to your production line, or even better at the water spider station when you would see all the warnings and alarms. And if you are also managing low-level warnings, for example, that's also useful because you will have everything at the same place and you can replace easily the components when you need to. So now you don't want to place expired or about to expire parts on your PCBs. So with active interlocking, you will make sure to interlock your machine via the placement machine software. So you can then take action before the parts are actually placed, because the machine will stop and will not be placing the expired components on the boards. And well, MSD, it's released and it lives on the PCBA. So even when the parts are placed on the PCBAs, they are still alive. And the management and the control of these sensitive components continue as they move through the downstream operation. So there are important considerations your MSD control system should account for, including that the MSD has enough remaining floor life for both top and bottom operations. So you can enable verification to make sure your components have a minimum remaining floor life in order to be placed on a PCBA. So these checks can be done automatically for you, and it will prevent you placing parts that won't be able to survive the top and bottom process. So that's a key element to take into account. One thing to know also is that bare PCBs themselves can be moisture sensitive. So it depends on several design factors, such as the laminate used, the number of layers, the board thickness, and flexibility. So as with components, the moisture absorbed into the PCBA can lead to serious damage when the board is subject to the high temperature of reflow, wave soldering, or selective soldering process. But unlike MSD components, the JEDEC standard does not define moisture sensitivity levels for bare PCBs. So as a result, there is no universal floor life clock for boards as there is for components. So within our system, you can also handle the bare PCBs as MSD components. So that way you will be able to apply specific moisture rules and requirements, such as baking time, temperatures, etc. And as with MSDs, to be controlled properly from a moisture sensitivity standpoint, they need to have a scannable unique ID, so that way you can properly track them. You will then be able to track the storage of boards into moisture barrier bags, limit the exposure time outside of sealed packaging, and bake boards prior to their assembly. The last part of our walkthrough is bake management. So when a MSD part exceeds its allowed floor life, it needs to be re-dried to eliminate the absorbed moisture before it can be used again in production. So there's different type of baking, low and high temperature. It's all available to reset the clock of MSDs close to expiration. So to choose the right type of baking, it depends on the parts MS level, the thickness, and package type. So certain type of container do not support high temperature baking, for example, tape and reel. So you really need to take that into account when choosing the temperature at which you will bake the component. So our system manages the different temperatures and timing as per the JEDEC standard, which is 40 C, 90 C, and 125 Celsius. So in order to start the baking process, you need to start the baking into your MSD management system, and then you just have to wait until the MSD Control module lets you know that the baking process has been completed to remove the part out of the oven. So the bake process really needs to be tightly controlled. You need to make sure that the components are baked at the right temperature for the right time. And also you need to reduce the number of bake cycle in the components to reduce the stress on it. Because if you bake it continuously, it will impact the material for sure after all these redrying process. I just want to add a small note on baking at 60 C. I know a lot of people are baking at 60 C because, well, a lot of tray carriers, packages, or labels do not support high temperature. And if you bake at 40 Celsius, it can take more than a week. So it's a very long time to wait for your part. So engineers often choose to bake at 60 Celsius, even if it's not part of the specification. So is that a good practice or not? Well, it's fair to say that baking at 60 Celsius, it's practical, and it's generally a low risk approach when you follow the correct procedure and time. But still, the risk is there. If you don't bake for the proper duration, it can lead to latent defects on the field. You then risk incomplete moisture removal. So just make sure you are using the right calculation. So to summarize this presentation, you can see managing MSD Control as making sourdough bread. So the key elements involve understanding the material, controlling the environmental conditions, adhering to timelines, and rigorously testing for quality. That's very important for the bread, especially. So each step has a direct impact on the end product. So making both processes and a blend of art and science. So once you've picked a holistic software solution to manage your MSDs, then you will have more time to perfect the art of sourdough bread making, or just eat it if you prefer to just eat it. So that summarizes my presentation. I'd like to thank you for your time. And if you're hungry, because I've talked about bread, for more information about MSD Control, or you just want to treat yourself with an early free gift, take the time to read our white paper, and don't hesitate to reach out to us if you have more questions about MSD Control.
Thank you, Julie. Thank you for the presentation. And yeah, the MSD Control ebook can be downloaded on the Cogiscan website. So yeah, feel free to download and get some more information. So thank you for the presentation. And we could already move on to our last topic of today, and which is Albert. I'm going to share real quick. So Albert is doing a presentation on microstops monitoring. Albert, you're already there, right?
Yes, hello. Evening.
Yes,
hi guys.
I can already see. Yes, all right.
Okay, thank you for that. Let me jump to the presentation. Hello, nice to be with you. Thank you, Alina, for the introduction. guys, I am Albert Pawła. I'm the product manager from Accevo. As we were already introduced, we are quite new to the group, but thanks to the experience that we have and thanks to the synergies that we've achieved together, we can also present our products. So we will be talking about the OE and microstops intelligence. So how to monitor the data and focus on the data-driven decisions to drive the efficiency and performance of your factories and of your lines. It's important to have the visibility of data and also to have a process in place how to make ways of working around the data. In Accevo, since 20 years, we are supporting and observing our FMCG, pharma, tobacco, and other high-volume customers on how to present the data, how to gather it, and also how to drive improvements from based on these learnings. So quick info about our values. We always aim for increasing the employee ownership, which is a key on operating machines by humans, to introduce standard ways of working, and also to support the best practices and other proven frameworks of continuous improvements, like IWS, Stop the Stops, you name it. There are different lean frameworks. However, the system is proven to support key of them. And if you are considering introducing any of the standard frameworks in your factories, this is a way forward. What do we do is the 3 key products. One is this data monitoring, microstops and OE intelligence. Second pillar is the paperless and EBR. So this is to map the processes, how to work with the data, how to work with task lists, and how to standardize and digitalize the processes in the data, and to find the synergies with having the systems in place. So not only to transform from paper to digital, but also to leverage from having all the data already in the system and that we can present it in the contextual way. And of course, the MES MOM, more focusing on the high volumes FMCG and pharma industries. Today we'll be talking about microstops intelligence and about the synergies with other products. So where to start? Nowadays, there are already many monitoring ways in place. Usually the machines itself have some extent of monitoring built in, but there is still no unified platform to see the data and to serve it in the way that it's nice to humans, let's say like that. Of course, there are like OPC foundations and other initiatives to standardize the data, which we are following, but the system is offering more. So not only data digitalization and data gathering, but also presentation of this in the way that operators and analytics can benefit from. How we can start is with the basic connectivity. I will show it to you on the next slides. So just to connect a simple signals to the production and to monitor if the machine is running or standing still, and put it to the system so that the basic KPIs and basic live monitoring can be introduced. And this already introduces huge benefits for the long-term optimization and also visibility of some low-hanging bottlenecks. But nowadays, most of our customers already go into full microstops intelligence, so to connecting to the actual PLCs or IPCs and to gather the data about the micro stoppages and about each concrete reason of the stop of the line, and later on presented in the Pareto and statistical ways, so that you can easily see the top stops and top reasons of your losses. Further way is to also track the rejection volumes and the scrap or waste. And later on, once the easy steps are achieved, we can also support you by focusing on the rate loss elimination and all these operations around the data, so daily management system and the paperless process. What is the key to achieve this is the machine connectivity. And this is something we are doing from this 20 years, so from the very beginning. And we are proud that from all standard machineries and also custom built, we are able to take out the detailed data about the reasons of the stoppages, the machine parameters, so center lining, and also the reasons of the rejections. We support all latest and also legacy technologies and data exchange methods. For some of them, we've also developed our own ways how to connect to the legacy machines and take out the data, because we are aware that some lines will still be with us for next years. But of course, we are following the latest trends as well. We offer end-to-end connectivity with the investigation of the backups, with the installation, just to take machine and put the data into the system. And the architecture is based on the edge devices and the servers, which means that with the standard approach, we can connect in the same way and build the systems on premises or in the cloud. Lately, we are implementing more and more systems in the cloud, so the architecture is optimized for this. And also all the software deployments are there to support this. However, this can be also applied to on-premises installations. What is also important to mention here is that we can advise on how to build the networks, and also we always aim for minimal changes or non-changes in the existing software, which means that for most of the cases, we can go connect to SE's machines that you have with limited or no changes, and extract the data, which is one-to-one with the HMI data, and put it to the standard system. Before, I know that it's a bit late, but okay, let's focus on the theory. Just the facts that we need to keep in mind. OE, which is the overall equipment efficiency, is the performance factor. Usually for the factories, let's say that the starting point is around 50%, which means that there is a huge room to just improve the efficiency even by a couple of percent, and to get instant boost in the ROI and in the capacity of your lines or factories. And out of this, the first step, as I showed you on the roadmap, would be to focus on unplanned downtimes. It turns out that if it was not tracked before, it can be that up to 2/3 of unplanned downtimes is caused by micro stoppages. So by really short interruptions or short stoppages on the line, which is a lot. And it's not so easy and not so obvious to track without that digital system in place. And once we put this and we make sure that the data is reliable and going live, the first gain is that now the management see what's the actual status, how much efficient do we go, but also where do we lose this efficiency, because this is the key factor not what's my performance, because this is probably tracked anyway in your factories, but also why are we at this stage? So what's the factor of unplanned downtime, planned downtime? What's the factor of the rate loss? And also what's the factor of the scrap? And in this case, the question to you is, are you aware of what's your percentage of unplanned downtime, and do you track it? Thanks, Alina, for the poll. So this is the question to all of us. And what's the gain here as well is once the operators see that we are tracking this and we engage them and guide them into the process, how to manage the data and how to give feedback about the key reasons of the stoppages, it instantly increases the employee ownership, which means that after guys get familiarized with the data, they want to make it better and they want to see their KPIs on the good level, on the level within the target. And all the methodologies and all the experience say that it's worth not only to focus on like main KPIs, but also to focus about the elimination of the number of stoppages. Because when the machine stops, even for a short while, it's not only the time spent on the stop loss, but also is ramp down, ramp up. It's also probably some material that needs to be wasted. It disrupts the machine joints, everything. So, and it can be also a mark that machine is not in the base conditions, that there are some issues, bigger issues, waiting for us and will appear because of there is increased wear and so on. So it's not to treat it lightly. And that's why we have this MTBF, mean time between failure KPI, which is the standard in all of the books to track it, to track the number of stoppages or the frequency of stoppages, and also to use it as a benchmark. And having this in mind, let's go forward to the next slide, which is the gains and how to introduce this. So first, the basic connectivity. So the connectivity with limited visibility. And this can be achieved only either connecting to one or two sensors on the line or to the last machine on the line, or to installing even the sensor, simple sensor, and connecting to the line. And this is like really quick to achieve. What we did in the past also is that even for the proof of concept, we have like predefined small on-premise server that we just go install and put it there. If there is easy to connect to cloud, we can also do it for the cloud to deploy it in our cloud and make you see it. But usually for this kind of things, it's more time spent with IT on the preparation than on the connectivity itself. But what's important here is that we have true signals of the machine run and true production volumes spread in time. And that this is served to the operator life and also to the later analysis life. What's not yet there is the reasons of the stoppages. And for this, we can ask operator by highlighting or by putting this into the process to manually override some stoppages into the actual reasons, which will give us some visibility. Usually it's used for the tracking of the breakdowns or of the process failures, so of the longer stoppages and reasons, and to just be aware what's my number of micro stops and how do they contribute to the overall losses. But it's a good start. And what's the next step? And again, right now, 70% of our customers already go to the next step from day one. So OE and microstops intelligence, which means that we automatically know what are the reasons of the stoppages and put it to the system in the standard way, like every type of machine, every line have the same format. The important thing is that the standardization is, of course, the part of our implementation. And once having this in the standard way in the system, you can introduce any continuous improvement framework that you find interesting. Our preferred are AWS or Stop the Stops, so we are ready for it, and we can also support you in a way how it can enhance this kind of methodologies. But it's good to stay simple, like focus on the Pareto of stop reasons, focus on top 3, top 5 stop reasons, and track the resolution of it. And of course, engage operators and engage the process leads to make sure that they understand where their losses come from, that they propose ideas, what to improve and how to improve. And what is also important, that once having this data, you can think about what to invest in. Like you have the data that, for example, a stop A is 5% of all my losses. So if I decrease it by half, I know that my OEE will be up of 2%. And in this case, you can easily build a business case and know what to expect once you invest in improvement of the specific machine part or in the training of specific operators or so on. What's still good here is that this has a lot of synergies in the further systems features. Like this can be a great input for the advanced planning system. And in fact, we are doing that with a couple of our customers already. This can be also a good input for the daily management system. So for example, root cause analysis, that you know that there is a problem, you have a standard way how to describe and deal with the problem. But from the system perspective, you already get all the data, what was going on that line, was it in the base conditions, what were the stop reasons, what's the trend, and how to mitigate that. What is also important here is that it will give you the instant feedback on your actions. So once having this visible on the shop floor, and you decide that, okay, you want to focus on the particular stop reasons on the particular line or group of lines, it shows you live KPIs hour by hour and shift by shift. So you can see, okay, when I'm doing my corrective action, and you can see what's the effect on the next hour or on the next shift, and immediately tune your actions or decide to change something or see that it's working well and capitalize on that. Going further, it's like all this system is based on that we recognize the stop reason. And how do we do it? Especially for the complex lines. It's to have a model. How do I define that my line is stop? And how do I find the root reason of the stop of my line? So in this case, it's not to connect every machine and put all the data as equal, but to put a logic in place which will define what's the loss and what is just a consequence of the loss. So what are the concrete reasons and what is just a noise, because these are, let's say, secondary or consequential reasons. And to this, we do this modeling for you as first step, and also what we do is teach you how to do it further in case of any changes or any other ideas. So first thing is the definition of when do I say that my line is running or when do I say that my line is stopped. There are a couple of approaches. Most common ones are just my line is giving output on the last machine, or my most expensive or most complex machine is running or is stopped. But we can implement also any other logic and how to define it. And second step is to mark what are the secondary and what are the main root reason stoppages. In this example, the definition of the line stop is that if the first machine is stopped, this means that line is stopped, but the reason can be anywhere from the line. And the red stops means that this is internal issue on the machine. Blue stops means that this is because of the next machine. And having this in place, the system is able to automatically assign each stoppage with its own reason. And it's not only which machine is the root reason of the stop, but also what is the... Okay, I will use the pointer. So not only which machine is the reason of the stop, but also what's the actual stop reason. So what part of this machine is fault, but also what was the message generated. And thanks to this, it's a great input for further development and also for recognizing the losses and the KPIs. What's also important is at this level, sometimes the reason of the stop of the line is just a stop button pressed on some of the lines, but it will be detected here as well and marked for further description of the operator, which means that if we anyway have the stop reason as a stop button pressed, it will be there initially, but we will encourage operator to overwrite it manually anyway. But this is the only manual action that operator should take, to just explain why he decided to stop the machine by the button and that it was the root reason of the stop of the line. To go further. Once we have this operator guidance and focus on really top things, and we have the good data, we present it in the loss tree. So in the drill down analysis of the reasons of the stoppages. And here we go from the very general, like the percentage of micro stops, and we can slice and dice through this data to go to really, really detailed stop reasons, usually to assign like stop reasons to 0.01% precision of where my losses come from. And also, of course, what are the trends, what are the correlations with the SKUs, with the material used, and so on. Again, this further increases the employee ownership and also gives you this kind of feedback and gives you the top things to focus on. And this is a ready framework to introduce and to use for the daily improvements in your factories. On top of that, because once we have the connectivity to the machines, we can take out all the data that's there. And what we also aim for is to take out the counters. Of course, the production counter, but also the rejection counters. And also, if the machine is capable of counting that, the reasons of the rejections. So why the machine decided to put something as a reject. And we have ready screens and analysis to put this and to analyze this under many domains, and also to drill it down into losses of materials. Because for rejects, it's one, the statistical loss of your efficiency, but on the other hand, it's also the loss of money because of that you need to scrap your material that was purchased for the end production. Going further, what we have for this is the synergies. So the microstops and oil loss tree monitoring is really first step for the improvements and for the digitalization. And it could give you even 2 digits increase in the OE for the first couple of quarters, because operators now see where their losses come from. It's transparent and live for everyone, and easy to focus on first improvements. But once we are there and once the first improvements are in place, there is always appetite for more. And how to do it is to follow the path that was already done by others. So to introduce daily management system where the machine set points, so the center lining is tracked, the defects are tracked, either with the simple method or with the CMMS-like system. The changeovers are managed, the problem solving is there, and all other components. And going from the data perspective, it's to also monitor not only planned and unplanned downtimes, but also rate losses. And for this, we have a couple of proven methods how to monitor them, but it's a topic for completely different presentation and different timings. Guys, being aware of time, thank you for your attention here and thank you for the attendance. We invite you to our webpage. You can scan the QR code and see for yourself. And also, if there are any questions, happy to answer, or you can reach out via email later on.
All right, so let's just quickly take over the screen as we are already at the end of our Smart Factory Summit. So thank you, Albert, for your presentation on microstops monitoring and for basically concluding our session. So yeah, first of all, a big thank you to all of our speakers who presented their topics today, and also for your participation from the audience. And we hope you leave with some fresh insights for your own production, and maybe we helped a bit to open some doors for your next steps within your factory. So who knows? If you have any further questions, feel free to reach out to us. We will get in touch with you probably next week with a follow-up, and you will then also get the recording of the session. So for people who couldn't join for the whole session, that is not a problem. You can rewatch the whole thing. And yeah, like I said, please feel free to reach out for any further questions. And we all wish you a pleasant evening. So thank you and goodbye.